another episode of Mr. Boskin Does Some Math. Today we are doing Illustrative Math Grade 8, Unit 7, Lesson 14, Practice Problems. Our first problems here are evaluate each expression, use scientific notation to express your answer. Our first one, we have two terms in scientific notation in parentheses. Parentheses next to each other mean multiplication. So we're going to start out by multiplying these. 1.5 times 5 is 7. 0.5. 1.5 times 5 is 7.5. Times 10 to the power of multiplying, so we add the exponents. 2 plus 10 is 12. Okay, our next one is division. 4.8 divided by 3 is 1.6 times 10. To figure out our power, we're dividing, so we subtract the exponents. Negative 8, subtract negative 3. Subtracting a negative is adding. Negative 8 plus 3 is negative 5. Okay, here we are multiplying again. 5 times 4 is 20 times 10. Multiplying, so we add the exponents. 8 plus 3 is 11. Okay, now we are dividing again. 7.2 divided by 1.2 is 6 times 10 to the power of dividing means we subtract the exponents. 3 subtract 5 is negative 2. Okay, now, how many bucket loads would it take to bucket out the world's oceans? Write your answer in scientific notation. The world's oceans hold roughly 1.4 times 10 to the power of 9 cubic kilometers of water. A typical bucket holds roughly 20,000 cubic centimeters of water. There are 10 to the power of 15 cubic centimeters in a cubic kilometer, which means we are going to want to convert one of these so that they are the same unit. This is cubic kilometers. This is cubic centimeters. So we have to convert one of those. Which one do we want to convert? Well, this one's not in scientific notation yet anyway. So let's start out by doing that. That would be 2 times 10 to the power of 1, 2, 3, 4. 20,000 is 2 times 10 to the power of 4 cubic centimeters of water. There are 10 to the 15 cubic centimeters in a cubic kilometer. So if we want to find out how many cubic kilometers a bucket is, we will then have to divide this by 10 to the power of 15. No number here, so that would be 1. 2 divided by 1 is 2 times 10 to the power of 4 subtract 15 is negative 11. So now we know it is 2 times 10 to the negative 11 cubic kilometers per bucket. Now to find out how many buckets there are in the whole world's oceans, we are going to have to do some more division. 1.4 times 10 to the power of 9 divided by 2 times 10 to the power of negative 11. Okay, 1.4 divided by 2 is 0.7. Half of 1.4 is 0.7 times 10 to the power of 9 subtract negative 11. Subtracting a negative is adding. 9 plus 11 is 20. Now, this is not in proper scientific notation. We don't have one digit in front of the decimal point. We want one digit in front of the decimal point. If we're making that number bigger, we have to add 1. Nope. We're subtract 1. There are 7 times 10 to the power of 19 buckets in the world's ocean. How many bucket loads would it take to bucket out the world's oceans? 7 times 10 to the power of 19. Okay, our next problem. The graph represents the closing price per share of stock for a company each day of 28 days. What variable is represented on the horizontal axis? Days. If this is 28 days, the share price depends on which day. Days 0 to 28. This said 28 days. What variable would be on the vertical axis? Closing price. In the first week, was the stock price generally increasing or decreasing? Well, in our first week, from day 1 to day 7, that is increasing. During which period did the closing price of the stock decrease for at least 3 days in a row? So we are looking for a long decrease. From here to here, that is day 7 to 10. Day 7 to 10 is at least 3 days in a row. Day 7 to day 10. Write an equation for the line that passes through negative 8.511 and 5 negative 2.5. Y equals mx plus b. The first thing we're going to want to find out is our slope. X and y. First point. Second point. We need to use our slope formula, which is y2 subtract y1. Negative 2.5 subtract 11 over x2 minus x1. 5 subtract negative 8.5. Okay. Negative 2.5 subtract 11 would be negative 13.5 over 5 subtract a negative is adding, so 5 plus 8.5 is 13.5. Negative 13.5 divided by positive 13.5 is negative 1. So now we know our equation is going to be y equals negative 1x plus b. We don't know what our intercept is yet, so let's take one of these points and substitute it in to the equation that we have right now. Which point do we want to use? It doesn't really matter. Let's take the first one. The y value we can substitute in is 11. We want to substitute in the x value, which is negative 8.5 plus b. Now, in order to solve this for b, first we need to distribute. Bring that down. Negative 1 times negative 8.5 is just positive 8.5. Now, to isolate the b, we have to get rid of this 8.5. To get rid of a positive 8.5, we subtract 8.5. Those will cancel. B is equal to 11 subtract 8.5, which is 2.5. So now we know B equals 2.5. We know our M is negative 1, so our equation is y equals negative 1 x. This could also just be negative x plus 2.5. Okay, our next question is explain why triangle ABC is similar to triangle CFE. So there are different ways we can do this. The first thing I would like to look at is there a consistent scale factor? Well, this side length is 1. This side length is 2. This side length is 2. And this side length is 4. What's the scale factor look like so far? 1 times 2 is 2. 2 times 2 is 4. Those both look like they have a scale factor of 2. This side length here is a little harder to measure. However, this goes up 2 over 1, and this goes up 4 over 2. So that gives us another consistent scale factor. Up 2 becomes up 4, over 1 becomes over 2. So that looks like a scale factor of 2. What about the angles of these two triangles? This angle here is a right angle, and this angle here is a right angle. We can tell because they follow the lines on our graph. Now, if this angle here goes from our line to horizontal, and this angle here goes from that same line to horizontal. Those two angles have to be congruent to each other. This angle here goes from our line to vertical, and this line here also goes from our line to vertical, so those angles have to be congruent. So all of our angles are congruent to each other, and there is a consistent scale factor of 2 going from the small triangle to the larger triangle. Okay, this has been another episode of Mr. Boskin Helps You With Your Math. Thank you for tuning in.